confidence interval for the population proportion. I'm trying to make it clear, okay? I'm trying to explain it, but if you really can't get it, what you need to do is just remember a formula, and that's it, all you need to do. So what is a confidence interval? Okay, confidence interval. Let's think about what we have done so far. Okay, for the three method, we use the NCR thing to calculate when it's a small population and everything like is given quite clear, and we find a sample of 3 or 4, and then we find the sample proportion. And I said that's not real. We don't really need to do that. If you just have 10 things in total, why we need to do a sample of 3? There's no point of doing that. It's not practical. We can only do that in a math question. We'll never really do that in real life. And then think about the second one and the third one for the mean and standard deviation. What you need to know is the number of sample, like how many people you're taking, which is the n value. Okay, think about the formula. How do you get the expect value? The expect value is p, and how do you get the standard deviation? It's p1 minus p over n. Okay, this n represents the sample size. Well, that's some information I will definitely know, because how many sample I take, I know that. Think about this p. What's this p represent? What's this p represent? Is that sample proportion? P. This P. Population proportion. Okay, it's not called sample proportion. Population proportion. Have a think about that. Will you know the population proportion if you are not the God? Will you know the population proportion? If you know that, why you need to do sampling? If you, that's all I need to think about. Well, 65% of the people have driver lessons. If I know that, what's the point of finding samples of 1,000? I get different values. If I already know a big data, if I already know P, what's the point of doing something else, right? Like this P, give the P to you is not a real thing. You're not going to have this P. Okay, although this P given to you is not going to be exact. So we can't work out the P. That's why we need to find the sample. So when we have the assumption P is that, it's not really something real. Like in a real life, we do samples because we're trying to work out the P value. We're trying to have some idea about what's the proportion of females, what's the proportion of people having driver lessons. I also have an idea. That's why I take samples. Not because like I know what's P and I'm trying to go backwards. Oh, find the sample, find the probability your sample will be the same as your population proportion. What's the point of doing that? It's like very useless. So what we talk about for this lesson is doing the right way. Okay, think about the right thing about sample. We have no information about P. Okay, we don't know P. We don't know P. What we're trying to do is we want to find a sample. Well, this what we learned is called a point estimation. We just use one sample to start the discussion. Well, you know, if it's a real life situation, we need to find more samples, like couple of group of samples, and then compare the sample proportion you get and then calculate a couple of times. But like in the exercise we learned today, we only talk about point estimation. We just use one sample. Well, I take a sample of 25 as this class, and that's it. Okay, and I do some assumptions from that. I do some calculations about this. What I want to do now is, I have no idea about the population proportion for a population. And then I will take a sample of size n. I can work out the p hat value from this sample size n. And this p hat value will give me some idea about where's my real p will be. Okay, I'll need what's the purpose of this exercise is I use a sample. I use the small p hat value from that sample to gain some idea about where's my real p will sit it. Well, you know it's not going to be exactly at the place you find. Well, your p hat value is not necessary to be the same as your population proportion. So it can vary. Your p-value can vary. But there will be a range for your p-value varies. And then you're trying to think about where's your p. How confidently I can say my P will be in that range. Okay, so that's all I want to do for this exercise. Okay, think about this. P hat is normal approx distribution for P as square root P1 minus P over N. That's what we learned yesterday. Okay, that's what we learned yesterday, which is the what is called like the normal approximation, right? It's the normal approximation. I will make assumption first, like N is large enough. Okay, N is large enough, and I'm trying to use the approximate probability to think about the confidence interval. I can't use the binomial one. Okay, I must assume P hat is a normal distribution first. Okay, we start from that. You don't need to remember any of this proof. Okay, you don't need to remember any of this proof. I just want to show you why we have that in the end. Okay, first of all, what do we know? Okay, we start from that. What's that? Remember what's that? Yeah, standardized normal. And you know, like, what's 95%? How many standard deviation you have 95%? 2. And I said 2 is not exact, right? Remember, 2 is not exactly the 2 standard deviation that give you 95. The exact distribution will be 1.96 to positive 1.96, give you 95%. So I use a relatively more accurate value. Okay, I use a more accurate value to do this calculation. So I'm not taking negative 2 and 2. I take negative 1.96 and 1.96. How do we work out the 1.96? Do you know that? How can I work out the 1.96 by calculator? It's not really 2 standard deviation. It's a Z curve, right? It's a standard normal distribution like that. Okay, 95% from a value negative K to a value positive K. Okay, symmetrical area, that gives you 95%. Okay, what's the area here? Yeah, 0.025. To the left-hand side of negative K, we have area of 0.025, right? And mean standard deviation for this distribution is 0 and 1. So what I need to do is menu 553 inverse normal 0.025 and with the same mu and standard deviation. That gives me negative 1.95. Is about 1.96. Can you see that? That's about 1.96. K is 1.96. That's how I worked it out. Well, 2 and 2 is good, but it's not good enough because it's not really exact values for 95%. That's the exact values. I will get 95% of the distribution. All right. Do we understand that first? Like, why we have 95? Well, this 95 is not always true. This 95 can be 99, can be 90. I need to adjust the 2 value here as well. But it's using the same method to work out what's the K value. Like, and then you adjust the 1.96 and the negative 1.96 according to what the percentage is. Okay, we start from that. Okay, let's have a look at this. Why might Z become that? Why that is set? Give me a formula. Which formula we are talking about here? Yep. X minus mu over standard deviation will give you Z. So P hat, mu is P and standard deviation is that. So we just convert that in. Okay, we just convert that. So capital P hat minus the mu and over the standard deviation will give me Z. So Z will be replaced by that. Okay, all good for that. Next one. What I have done next one is I just times standard deviation on both sides. You see that? I just times the denominator on both sides of the equation, and that's it. Okay, from this step and this step is a little bit confusing because I don't want to leave P hat in the middle. I want to leave P in the middle because I want to get a definition. I want to get an idea of what P is. Okay, what P is less than something, P is greater than something. The probability that P is less than this, greater than this number and less than this number give you 95%. So what means I'm 95% sure my P will live in between these 2 values. Okay, my P will live in those 2 values. So what I have done from second last step to last step, I have minus, okay, I have minus the equation on both sides. Okay, I'm just thinking about the inside, I'll minus it. I'll times -1 on everything. Because you times minus, the sign will flip. You have minus capital P hat and plus P. And then sign flip, minus 1.96 times square root. P1 minus P over N. Okay, so that's what we have. I want to leave the P in the middle. So next step is I will plus the P hat on both sides of the equation. Okay, I'll add the P hat on both sides of the equation. So that's the P hat plus 1.96. That P1 minus P over N greater than lowercase p greater than P hat minus 1.96 square root P1 minus P over N. What all I have done is just keep rearranging the inside. Okay, keep rearranging the inside. Now, after that, what we have is this. Probability that P hat minus 1.96 times square root of times the standard deviation less than P hat plus 1.96 times blah 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 is 95%. So this is a value. Okay, this is a value. I can calculate that. I know the N. Well, I'll explain that more. So I can calculate two values out for those two places. So which means my P hat in between those two numbers is 95% sure. Okay, the probability that your P is in between that two numbers is 95%, which means my P hat 95. I'm 95% confidence that my P will sit in between those two values. So I just need to work out the two values. Okay, let's say this is A, this is B. So I will say in between A and B, this is my confidence interval. This is my 95% confidence interval. Okay, so this is not necessarily always 95. It can be 99%, it can be 90% sure. All I need to change, nothing will change except this 1.96. Okay, that's the one. Where do we get the 1.96? It's from the very beginning. Because it's 95%, cover 95%, that's why we have 1.96. But say if I want a 99% confidence interval, I will have 2.58 here. Okay, I'll have 2.58. Why? This is a standard normal distribution, and I have from negative K to K, I have 99%. I have 1% on each side, right? 1% on each side. So, not each, 1% like in total. So what we have here is 0.5%. Okay, is 0.5%. So, that's menu 553, 0.005 with 0 and 1. I have negative 2.575, so it's approximately negative negative 2.58. And for C% confidence interval, I just need to find the K value which can give you on the Z curve that can give you the C%. You see it's 90 if C is like 9. Normally it's 90, 95, 99, but it's not good to have any other values. It's normally those three values. Okay, so what is a confidence interval? The confidence interval is the two values we calculate on each side of this inequality. Okay, that's from A to B. That's how, well, first of all, you can calculate your P out, right? This is a capital P. This is a capital P. But because we do a point estimation, this P will just be your lowercase p in the sample. You can work out the lowercase p, and that's just your sample. Okay, that's your P hat. So that can be changed to a lowercase p hat. Okay, can you see we still have P here? We still have P here. We still have P here. Those two P is not good enough because we don't have information about that. Instead, we will approximate that by using the sample proportion in my sample. Okay, I will approximate that into a P hat value. okay, into a p-hat value. So can you see in the end what's the 95% confidence interval becomes? Is the lowercase p-hat minus 1.96 times the standard deviation. But the standard deviation is not calculated by using p, it's using the p-hat. Why? You don't have information about p. You can just assume that your p is the same as your p-hat for this sample. And then that's how you do the calculation. And then that's two values. Can you see you know the p-hat, you know the n. I can work out two values, say 0.5 to 0.6. I'm 95% sure that your actual p-value will lie within this range. Okay, will lie within this range. Have a question. Is there any chance that your p is not actually in this range? Yeah, okay, it's only 95% sure. You're not 100% sure. So there's always chance that your p is not actually lies within this interval. All right, let's do an example. Okay, just remember what? Remember this. P-hat minus k. How to work out k? Just the inverse normal to work out k. And times the standard deviation. Okay, it's basically the mean times minus k times the standard deviation and the mean times plus k times the standard deviation. But the standard deviation is calculated by using p-hat, not using p. Okay, that's all we need to remember. If you don't understand what's my proving or before that, that's fine. All you need to remember is the last row here. Okay, it's the last row here. So I will just interpret this a little bit for you. I have an interval here. Okay, I have an interval here. The middle is my p-hat value. Okay, the middle is my p-hat value. The left endpoint is my p-hat minus k times p-hat 1 minus p-hat over n. On this side is p-hat plus k times square root p-hat 1 minus p-hat over n. What I want to say that is p-hat, like your sample proportion you calculate from the sample is in the middle of this interval. And you go left by k times standard deviation that much, and go right by k times standard deviation that much. Okay, that will give you the interval. So from this point to this point, I'm C% confidence that your actual mean is about here. Okay, your actual mean is about here. Okay, let's use the length of this interval to represent the actual length. Okay, to represent actual length. Let me know, like when you're trying to tell, for example, you want to tell me, oh, my actual p is in between 0.5 to 0.6. And then another person tell me, my actual mean is about 0.5 to 0.55. Which answer you think I will prefer? Like one is 0.5 to 0.6 and the other one 0.5 to 0.55. Which one do you think I will, not say prefer, which one is more accurate? 0.55, right? Like you have less value to vary. It's only for this much you can vary. But for the first person tell me it's about this much, you can vary, like you pick and less in between that. So what control the length of this interval? Okay, there are two factors control the length of this interval. Like how, do you have vary for a really large range or do you vary only for a very small range? It depends on two factors. The first one is the n, size of n. When n increase, length decrease. When you have more samples, you can be more certain and you can be more accurate. Okay? When you have a larger n, why that will happen? Think about this number here. Think about this number here. When n increase, what will happen to this number? Decrease, right? Will decrease. When k is a fixed number, when n increase, this whole number decrease. What you minus and what you add is shorter. And then the interval becomes shorter compared to a smaller n, right? That's the first place. And by reasoning is more sample will give me a more accurate value, like more exact value. That's the first thing. The second thing is the confidence level. When my P covered by more data, I will say I'm more confident. Well, when I say from 0.5 to 0.6, I'm 95% confidence. But when I increase the two side a little bit, when I go 0.4 to 0.7, I can say I'm 99 confidence. Well, like there's more thing. Like even though you increase your confidence level, what happened is you have a longer distance, and your P can vary from 0.4 to 0.7, which is a longer distance. Well, I can't say it's a good thing or bad thing. Just tell you how you will increase the size. So when like confidence interval is called the C%, that's the confidence interval. So what we will do is C% increase, the K value will increase. Can you think about that? The K value will move to the right hand side and left hand side will increase. And then what will happen is the length will increase. Because is K times the standard deviation. So if the standard deviation is the fixed value, like n is fixed, when you K increase, you minus a larger number and you plus a larger number. So you will move further to two sides. Okay, move further to two sides. So your length actually increased. So there are two factors influence that. One is the n value and the other one is the confidence level. So if you can if you want to get a smaller range for this interval, you can do two things. Either get more sample, like get a really large sample, like increase from 100 to 200. Or the second thing is to reduce your confidence level. I don't want to be that confident to say my P is there. I can be 90% confident the length will be reduced as well. Okay, that's the two methods. You will reduce the length of this interval here. Okay. Let's move on to the next one. All right, let's have a look at example 10. In a class of 20, okay, so n equals to 20, 17% of students are planning on going overseas during the term break, or going overseas during the term break. This 17% is not the population proportion. It's only the proportion in the sample. So this is the lowercase p hat value, which is the 17%. You want a 99% confidence interval. Okay, you want a 99% confidence interval. So remember the confidence interval is the p hat minus k times square root p hat 1 minus p hat over n to a value p hat plus k times square root p hat 1 minus p hat over n. So that's what I want. Okay, that's what I want. So I know my p hat, I know my n. What's my k value? What's my k value? Well, do you have that in the previous page? 2.58. Well, it's also the value I work out here, the 2.5758. Well, you can take more decimals from your calculator, that's fine. I'll show you that calculator method later. So let's just put this in, okay, just put this in. So I'll just use k equals to 2.58. Okay, it's good enough to use 2.58. So its p hat is 0.17 minus k is 2.58 times square root of 0.17 times 1 minus 0.17. P hat 1 minus p hat over n. N is 20. Well, I have done nothing. I just substitute the numbers in. Okay, p hat value, n value, and the k value in. I get the left-hand side interval. Well, do not copy that yet. Well, we can just write this down. And I'll do the positive side as well. Change the minus sign to plus. That will be the positive side, like the right-hand side. Press enter. I have 0.367. Are you going to take this negative? If you're not going to take this, what you will change that to? 0, because it's a p hat value, like it's a sample proportion. The lowest value you will get is a 0. So the 99% confidence interval is in between 0 to 0.3867. This is the lower bound. The upper bound is no problem. Whatever you calculate out, you can just take it if it's not over 1. But because the lower bound is out of 0, but we need to adjust that back to 0. Okay, let's look at example 11. I want to show you the use of calculator as well, and you will love it because you don't need to do any calculation. You don't even need to remember the formula. Again, the formula is stored into the calculator for you. Okay, let's have a look at that. An exit poll of 100 voters found that 620 favored candidate A. Okay, so out of 1,000, 620 favored candidate A. What you can work out from that? Or what will you know from that? N equals to what? 1,000. And what's your p hat value? 620 over 1,000, right? That's 0.62. I need also k value. Well, because it's a 90% confidence interval, what's the k will be? Okay, 90%. That's 90%. What has been left for this side? 5%, right? 10% in total, 5% each side. 0.05. So what you would do is menu 553, inverse normal 0.05, and it's a standard normal distribution. 1.6, well, I'm not going to take the negative, is 1.645. Okay, 1.645. Okay, round to 3 decimals. It 1.645. Is the used inverse normal 5% to calculate. Well, if I do it by hand, I can just put into the formula, right? P hat minus k square root p hat 1 minus p hat over n. And this side is p hat plus k times square root p hat 1 minus p hat over n. Well, I know all the values. I can just sub in to do the calculation. It's exactly the same. Like, I just need to work out 3 values, p hat, n, and the k values. How about if we use calculator? Okay, where we can find this to use calculator? We use menu, number 6, statistics, number 6, confidence interval. So menu 6, 6. And which one do we use? Okay. We use number 5, 1 prop z interval. Okay, 1 prop z interval. I think for special student, they use number 1 as well for another interval, but we use 1 prop z interval here only. Okay, only. The only one we use is menu 665. We click in that one. Okay, couple of values we need to put in. 3 things only. Sea level is very easy to decide in this question, which is 0.9, right? 90% confidence interval, that's the sea level. How many n do you have? 1,000, just put 1,000 in. X is what? X is the number of success. What do you have for the number of success in the sample? 620. You don't put p hat value in, you put 620 in, like it will directly calculate for you. Okay? Oh, no, cancel. Okay, so 620 and I have 1000. Okay, let's have a look. Look at the answer. Look at the answer. You need to know where you get your values. There's a C lower bound is your left hand side value, and there's a C upper bound which is your right hand side value. Okay? That's the two value you look at. And the p hat value, you work out p hat for you, which is 0.62. You know that as well. That's work out for you. You don't need to worry about the like is the minimum error, like you don't really need to do that. N is 1000, which is what I put in, and title, don't need to worry about title. So you just need to grab the two numbers from this. One is, well, if I give 3 decimal places is 595, 0.595, and 0.645. Okay, that's the two values we will have for the left hand side and right hand side. It will be the same as you plug all the numbers into that formula, and what you calculate out will be exactly the same. But what question? That one? Well, is your P, it's more like what's your population proportion? Say your population proportion will be lies within 59% and 64%. Well, you can say it's a percentage or it's just a decimal, but it's in between 0 to 1. It must be in between 0 to 1. Okay, so my 90% confidence interval is in between 0.595 and 0.645. Okay, your confidence interval. All right, next one. Okay, we are going to talk about one last thing. It's called the margin of error. So what's the margin of error? It means how much it varies to the left and to the right from your p hat value. So from your approximation, again, not the approximation, the sample proportion, how much you can go left and how much you can go right. That's your minimum margin of error. So remember the interval I draw it for you. P hat is here, and we have P hat is in the middle, and the right hand side is P hat K times P hat 1 minus P hat over N. That's the right hand side. And the left hand side is P hat minus K, P hat 1 minus P hat over N. Okay, so this is how much, well, from the sample you can work out this value. And how much go to the left and how much go to the right with the same distance. This is called the margin of error, like how much you moved. Okay, how much you move to the left and to the right is your margin of error. Well, your margin of error depends on two things, or three things, the K value, N value, and the P hat value. Okay, that's your margin of error. Sometimes they will see, oh, I want the margin of error only become 0.1, for example, only become 0.1. So you can equalize the K P hat over N equals to 0.1, and then you can work out what's the N value you required. Like say, the maximum margin of error can be 0.1. So what's your minimum value of your N? Like your N needs to be at least what? When you know the K and when you know the P hat. Nothing new, it's just what is margin of error. It's a new definition. You can move to the left, you can move to the right. That's your margin of error. Okay, just let's look at example 12. Okay, Example 12 is an exam 1 question. Okay, just remind myself, that's an exam 1 question. In exam 1, we not require knowing that 95% is 1.96. You not necessarily memorize the value, the 2.58 for 99%. You're not requiring remembering that. So when in that case, when they say 2 standard deviation, you just say it's 2 standard deviation. Okay, just use 2. They're not requiring you to use 1.96 in this case. Otherwise, they will tell you. So what we have done, what we have in this question is a sample size n is drawn from a population. The proportion of the population with interest is equal to P. Okay, the proportion of the population with interest is equal to P. Okay, so that's the population proportion, that's P. Exactly 2 standard deviation for P from a confidence interval is 0.7 and 0.79. Determine the value of P and the N. Okay, determine the value of P and the N. This question is a little bit different from what we have learned so far. But what all we need to do is, well, we have an interval. That's it doesn't say what confidence interval, but what tells you is 2 standard deviation. Okay, we are talking about the P distribution. We are talking about the P value distribution. So we have 2 standard deviation from the mean is 0.7 and 0.9. So my P must be in the middle. Okay, my P must be in the middle. And then 2 standard deviation to the left is the P minus 2 times square root P1 minus P over N. And then to the right is P plus 2 standard deviation, P1 minus P over N. Okay, it says exactly 2 standard deviation for P. Okay, so P must be in the middle and then go left by 2 standard deviation, go right by 2 standard deviation. Nothing to do with P hat. Okay, nothing to do with the P hat in this question. It's just for my P, and I have my P, 2 standard deviation to the left. You know the standard deviation for P hat is P1 minus P over N. So go to the left for 2 and go right for 2. So what's my P should be? 0.8. Then what you can see here is 2 square root P1 minus P over N needs to be 0.1, right? 0.8 minus 1, 0.1 equals to 0.7. And 0.8 plus 0.1 will give you 0.9. So my margin of error equals to 0.1 in this case. Okay, that's my margin of error. I can put that into the calculator. Menu 3.1. Oh, I'm just too lazy to do it. Well, I can do it by hand. Well, that's right. Just exam 1. So I can just go square root 0.8 times 0.2 over N equals to 0.05. Well, what's 0.05? That's 1 over 20, right? That's 1 over 20. Just use fraction. And what I will have here, well, this is 0.16. You square root 0.16, you have 0.4 over square root N equals to 1 over 20. Let's go that side. And then we cross multiply square root N equals to 8. And your N equals to 64. So I have worked out the P value and N value. P is that and N is that. Okay, so n is 8 squared, so it's 64. So cross multiply, you get square root n equals to 8. And then you have 64. Any questions for that? Okay, let's have a look at the last one. Okay, let's have a look at the last one. The manager of hospital is investigating the waiting time of patients in an emergency clinic. It has been found that the proportion of patients who wait more than 1 hour is 0.4. Okay, so in this clinic, you find the patient waiting more than 1 hour is 0.4. So your p-hat value is 0.4 for this clinic. The manager chooses a random sample of size n of patients from the clinic. So n is unknown. Okay, so n is unknown, and you work out the p-hat value is 0.4. The manager requires the width of a 99% confidence interval for the patients who wait more than 1 hour to be at most 0.3. Okay, so what you want is the width of this confidence interval. This is a 99% confidence interval. Okay, so you need the width is at most 0.3. Well, you know the C level is 99% already. Okay, so that's a fixed value. It's a 99% confidence interval, and you want that width is at most 0.3. Tell me something. How you can reduce the confidence interval in this case? There are two methods to reduce the length of the confidence interval, like the width of the confidence interval. What you can do now? Increase the n, right? It's either decrease C or increase n, but your C is a fixed value. I cannot decrease it anymore. So you must increase your n value. Okay, you must increase your n value. So what we will do is, again, this total is 0.3. Okay, the total length is 0.3. Well, what you will know, your K value is what? K is 2.58, right? It's 99% confidence interval. And we have that workout already before. Okay, tell me what's the margin of error in this question? What's the margin of error? The value of margin of error. 0.15, okay? Half of the width of the interval is your margin of error because your p-hat is here. And then you move p-hat minus k times square root p-hat 1 minus p-hat over n. So you move to the left only by 0.15. So your margin of error is 0.15 only. So k is 2.58 times square root 0.4 times 0.6 over n. This needs to be smaller or equals to 0.15. Your margin of error needs to be less than, because it's at most 0.3. So your margin of error is at most 0.15. And you can solve for n here. Over x, and that equals to 0.15, and I can solve for comma x. X give me 71.0016. Okay, so n needs to be greater or equals to 71.0016. What's the least number of n? 72. Okay, and at least 72. It can't go beyond, lower than 71.0016. So you can't take 71. You must take 72 here. Okay, so the width is not more than 0.3. So your margin of error is not more than 0.15. All right, just have a look. Any questions in the first 8 page? Well, especially what we learned today. Well, we learned today seems very complex, but it's basically just one formula. When you know the p hat value, n value, and the k value, you need to know how to work out the k value, and you know how to work out by using calculators. You will be fine. Okay, it's just substitute values in. Sometimes they will ask you about how to reduce the width of the interval. You know there are 2 methods we can do that. We can increase the n value, or we can decrease the confidence level. That's the 2 way. Normally we can't really reduce the confidence level. Like they want a 95 confidence interval. You can't do much about that. What you can do is changing n. That's the quickest way to do it. All right, any other questions? If you don't have any questions, that's the end of the course. We have learned everything so far, and we finished. Okay, congratulations, everyone. There's 2 more pages on the notes, but this is pure questions. It's not really new stuff. You can just try them. It's an application question. Yes.